So this was code for the previous ODP, right? And we kind of worked through most of this on paper, a little less explicitly yesterday. But basically, you have a global variable. I called it save value, and put just saves your argument into that global, and get just reads that global and returns it as the function value. So I think most people figured this out. So ODP 420 is very similar, except that when you give it two arguments, a location and a value. And when you say get, you give it a location. And put should simply take this value and somehow remember it in this location. And get just reads the value that was saved in that location. And your location is anywhere from 0 through 9, so 10 spots total. So instead of a global variable, you're going to have a global array that can hold 10 integers, and basically just take your value, store it in that location in the array, and then your get function just reads that element from the array and returns it. So it's a very small modification to what you probably did for 419, but have an array so you can store 10 different values. So I think that's all this basically says. So example usage, right? This is not exactly what your program should do. These are just examples, right? If you store 100 at location 2, 14 at location 1, etc., then when you call these get functions, it should return those particular values. Yeah?
When I try declaring an array outside of it, it says that the built-in function declares non-function. It doesn't
I see what you're-
Let me see what you put in your code. Maybe index is a reserved word. We're calling it something other than index.
So this would declare a global array that holds 10 integers, right? And that should compile fine. But I think index is a reserved, right? So if you try to call it index, it'll complain at you, but just call it something different. And then the rest of it's kind of the same as 419. All right, so good with that? All right, so what about PA4 questions?
So, I guess I'm a little stuck on as to how we're gonna get like a huge multi-line string and put it from standard in. I was wondering if you could expand on that.
Make yourself a big test file and just redirect it into PA4, right? If you don't want to type millions of characters, make a test file and just send it in, and it'll basically read standard in, but it'll come from that file. And if you're on the Linux server, there's warandpeace.txt/temp, and that's got 63,000 lines. So that's a good test file. It's a good thing. And it shouldn't take that long to process, right? So that takes about 3 seconds on my laptop. And you can run it through more.
Wow.
And so that's sorted by phrase length.
Is that in there now, warranties?
Yeah, it's on the server. And if you run this through sort, you'll see the most frequent phrases at the bottom. So yes is almost twice as frequent as no. I'm not sure. Is in there. And O appear more times than no. And this is potentially an interesting way to analyze a 68,000 word
My dear
novel.
fellow. 56 times.
So if you don't want to read the whole thing, maybe you can like write a synopsis based on this. I don't know. I've never tried. Prince Andrew is a prominent character who speaks a lot.
So does it follow the zip curve?
I don't know. I haven't checked that actually. That would be interesting because this is a lot older. I don't know if that's changed over time.
We might want to expand how many phrases we grab too.
Say again?
We might want to expand how many unique phrases we grab.
Yeah, because we definitely run out of it. Because a lot of these things are, they pop up once. It was too short for her teeth.
Oh.
Yeah, these are good fortunes too. All right, other questions on PA4? Yes.
So just when you type in the end file, you move the new declare, does that mess with the end file or should it still return the end file? Because I keep getting something different.
It's up to you. The most straightforward thing is just if it sees end of file, just return end of file and then process that
Do
outside.
you have to specify that or should it automatically just?
So you're calling like get car inside your get car, right? So if that returns, it depends how you wrote your get car function, but it may just come back as EOF if you're not doing anything special with it. But it doesn't hurt to put in a special check for it, right? If the character is EOF, return EOF. But there may be some things you can do that'll make life a little easier. Like you can bundle that up into an end of phrase character or something, but it's up to you. But if it's seg faulting, even if you read beyond end of file, it shouldn't seg fault. So if it's seg faulting, I'm not sure what exactly is going on. There's probably something. Are you building phrases? No? Okay. Come by and show it to me after class if you want. Yeah.
When you're passing a phrase into the save to index next, do you have to pass out the index and the count value?
You can. It's up to you. Ultimately, you need to somehow keep track of how many things are in that index. So it's probably convenient if save to index returns the size of the index after that phrase has been added. And then your main program can keep track of it there. But it's totally up to you. I'm not requiring those particular functions, and I'm not putting any constraints on what those functions do if you decide to use them. They're just kind of suggestions. But yeah, I think returning the size of the index is probably useful. Other questions? So I said I was going to talk yesterday about sorting, and I totally forgot to do that. So let's talk about sorting, because ultimately you need to sort your output by the length of the phrases. So how do you sort a bunch of numbers? One at a time, probably true.
you can sort them in order of increasing value.
Okay, so let's sort these from increasing value. How would you take this list of numbers and write down a sorted version of it? Just like as a human. Say what?
Look for the smallest one first.
Okay, look for the smallest one first. So the smallest one is a 1. So I'll put that down. And I'll underline it so I don't do it again. And then look for the smallest one in the remainders. That's a 2. Right? And look for the smallest one. That's a 3. Right? So that'll work. That's a sort method that's actually called a selection sort. You go through and you select the next number for the output, and you mark it somehow, and you keep doing that. So that's one way to sort. There's multiple ways to sort, and in 222 we'll go through a bunch of algorithms. But selection sort is one. Another approach is an insertion sort, which basically starts with the first number and puts it into our output list. So it says, okay, here's our sorted list so far. And then it finds the next number 7 and says, where should we add that to our output? Well, it should come after the 4. And here's our third number 2, that should come before the 4. And here's a 20, that should come after the 7. And here's a 16, that should go between 7 and 20, right? And it goes through your numbers, but it basically puts them into an output list so that the list is always in order. That's called an insertion sort. The way I'm suggesting you do this is something you probably touched on in 121 called a bubble sort. So, and bubble sorts are kind of like a selection sort, but they're optimized somewhat for working with your data in an array. And let me write our numbers vertically. So bubble sort, think of rocks sinking through the water, and little pieces of sand float up and bubble up to the surface. So heavy things sink and lighter things rise, even though everything sinks technically. So bubble sort is based on making a series of passes through your data. And the idea is each time that you make a pass through your data, another number ends up in the correct position. Okay, so ultimately we want 20 on the bottom, we want 1 on the top. Okay, we have 1, 2, 3, 4, 5, 6, 7, 8 numbers. If we make 8 passes through this data, all 8 numbers should be in the correct position. So what do we do on these passes? We start at the beginning and we move through and we compare each number to the number after it. And we try to make sure those 2 numbers are in the correct order relative to each other. So we look at a 4, 4 is smaller than 7, that's fine. We look at 7 and 2, those are in the wrong order. So we swap those. So 4 stays where it was. 7 and 2 swaps, this becomes a 2 and a 7. And then 7 and 20, those are in the right order, so that's fine. 20 and 16, those are in the wrong order, so we swap those. So this becomes 16 and 20. And then 20 and 14 are in the wrong order, so we swap those. And this becomes 14 and 20. And 20 and 3 are in the wrong order, so we swap those. And this becomes 3 and 20. And 20 and 1 are in the wrong order, so this becomes 1 and 20. And now, after one pass, we know this was the biggest number. And let me clean up our list of numbers. All right, so there's our numbers. And we just do the same thing again. So we compare 4 and 2, and those are in the wrong order, so we swap them. And 4 and 7 are fine, 7 and 16 is fine. 16 and 14 are out of order, so this becomes 14, 16. 16 and 3 are out of order, so we swap those. 16 and 1 are out of order, so we swap those. And our 20 stays where it is. And now
No, the second highest number.
Second highest number is in the second position from the end. So if we keep doing this, each time we'll get another number in the correct position. If we do this 8 times, we'll certainly be done. We may be done in fewer than 8, but 8 will suffice.
So you want to try to do as many passes to as there is numbers?
That's the safest way to do it, yeah. Now you can get fancier. You can go through here, and any time that you swap a pair of entries, you can set a flag. And if you get all the way through and you didn't swap any pairs, you're already done, right? And if you keep doing multiple passes, you're not going to swap any pairs on those passes either. So you're just wasting time. But we're not worried about efficiency, right? You're going to have a few 100,000 phrases. That's minuscule to sort, time-wise. So we can code this up as a pair of loops. So we want to do a total of n passes. And inside each of those n passes, we want to compare each number to the number after it. So we want to start with number 0. If you have 8 numbers, we only want to go up through number 7, because we're comparing each number to the number after it. All right, we're going to compare entry num to entry num plus 1. So this actually wants to go to n minus 1. And then we can say if data num is bigger than the number after it. So this is all sort. An array of integers, where n is the number of integers in that array. So your inner loop is basically saying for all of the numbers up to the one before the last, see if that number is bigger than the number after it. And if it is, swap them. That's really your whole bubble sort. So that's the end of one pass. That's the end of all passes. So that's pseudocode for sort of the most straightforward bubble sort. It does more work than it needs. You only really need n minus 1 passes. Because if you sort n minus 1 numbers, put them in their correct position, the remaining number's got to be in its correct position. But too much thinking, so just go from 1 to n. Because extra passes don't hurt you. Does that make sense? Right, so this is another piece of code that you can bundle together as its own routine and just pass it an array of numbers. Let it sort that array and then print out the elements in that array, and they should be sorted. So if you want to take a break from string processing and text processing, right, write a bubble sort. You can Google this, you can find bubble sorts online. Don't do that. Right? This is really, really good practice. It's a simple algorithm, but it forces you to do things like pass arrays and construct loops and nest loops and stuff like that. And if you Google it, I probably won't notice, but it's like a really good thing to be able to do and can pop up on tests. So, all right, so how do we swap two elements? How does the swap business work? So x and y are integers and we want to swap them with each other. What's the code for that usually look like?
temp equals x equals y, and y equals temp.
Yeah. Right, we'd like to just say x equals y equals x, but that doesn't work because x is equal to y, right? So instead of using x here, save x before you change it, and then set y equal to that saved value. Did you ever try swapping without a temporary?
I made that mistake.
But you can do it.
Yeah, no, I couldn't.
It's a fun thing to try to do. But yeah, you can swap two integers without having to use a third variable. So play around with that if you're bored. All right, so for PA4, we're not sorting an array of integers, we're sorting a dictionary of phrases, right? But that doesn't really change this basic algorithm, right? Instead of using data bracket num and data bracket num plus 1, we want to look at the length of phrase num and the length of phrase num plus 1, right? So something like if the length of phrases bracket num is greater than the length of phrases num plus 1. Where here I'm assuming phrases is this 201 by 1000 two-dimensional array of characters, right, or your one-dimensional array of strings. So your comparison is just on the length of those phrases, right? And to actually do the swap, you need to do something a little different. So string 1 and string 2 are two strings that you want to swap with each other, right? They're actually elements in your dictionary, but just imagine they're strings, which they are. So your temporary has to be an array of characters, 201, because that's how long your strings can be. And then I suggest use string copy. Right, because you can't just say temp equals str1, because that doesn't actually copy the characters. That changes temp to point to str1, and that's going to trip you up. So, man, string copy, right? String copy takes two arguments, a destination and a source. So string copy temp, string 1. And then copy string 2 into string 1, and then copy temp into string 2. Right, it's a parallel to what we do with integers, but you do it with strings. And that's a function you can write and bundle up and test the heck out of, and then sign off on, right? Swap. Right, just make a swap routine that takes two strings and changes their contents, and throw all that in there, and then you can test that by itself, and once it works, you can pop that into your Bubblesort right there. You don't have to like complicate your Bubblesort loops. Does that make sense? Right, so keep looking for opportunities to break things down into sub-pieces. You got to write the code anyway. It takes you a few extra lines to put on a function header on the top and maybe a return statement at the end, but it buys you so much, right? It will simplify the code that you use this in tremendously, and it'll make debugging easier and so on. So keep modularizing. I got another one. All right, so let's talk Linux again. So I posted a study guide for the midterm. Let's talk about that tomorrow. What? Friday.
That's so much
You're in a rush. Yeah, midterm is Friday. Well, do you want to talk about it now?
Yeah.
Okay. Since you're here, this way if it takes more than a day, we got time. All right, so there shouldn't really be any surprises in here. So basically 3 things that you're going to be tested on. One is basic Linux stuff. The second is C programming. The third is Bash programming. Okay, the majority of it is the programming. So probably about half C, half Bash, and then a few points from Linux stuff. So basic Linux stuff I'd like you to know, right? Basic commands: echo, cat, ls, change mod, move, copy, remove, word count, date, the stuff we've been using, the stuff you've probably been using as you write code, as you develop and move files around and things like that. Redirection of input and output using the less than and greater than sign, right? So we've talked about this. You'll be using it for PA4 probably. You may have used it before. So basically, you can say command greater than file, and the output of that command goes into the file. You can say command less than file, and it reads from that file instead of standard in. Right, so that should be familiar. Using a pipe lets us take 2 commands. The output of the first command becomes the input of the second command. Right, so typical example. Right, here's what ls does. This is what word count does. We can put those together and put ls into word count, and it'll tell us how many lines of output ls generated, right, which was 9 lines. So it lets you just chain commands together with one output becoming the other one's input. Quotation marks. So I'd like you to be clear on quotation marks. So in Bash, if we put something inside double quotes, it takes all that stuff and it groups it together as a single thing, right? But if there's something like, a $X in here, that gets replaced with the value of X. So X equals hello, Y equals, X is $X. If I look at the value of Y, it says X is hello, right? Because that $X up here said, go ahead and replace this with the value of X. So that's what double quotes do. Single quotes suppress that evaluation of $. So if I say X equals, single quote, X is $X, and then I look at Y, it's just X is $X. Right, so a single quote says don't expand $. Back quotes, what?
I was going to say it's just quite literal.
It's very literal, yeah. Back quotes are a totally different beast, right? So when you say back quote, you put in some command that says execute this command, capture whatever it sends to standard out. That's the value of this thing. So if you say something like X equals back quote date, right? This executed the date command, and then it said X equal to all of that stuff.
Back with the
did it.
Back when you did it, exactly.
So you can use that for like a last logged in or
Mhm.
last entered thing.
Yeah, definitely.
At least for bash.
So if I say echo quote the date is back quote date, right? When it gets to the back quote date, it'll execute the date command, and it'll replace back quote date with the output of date. But if you single quote it, I believe it will suppress that. Right, so single quotes, like you said, really make it literal. Double quotes interpret things like $sign and back quotes. So if I say echo your dir contains back quote ls, that's a lot of stuff, right? ls gets executed, back quote ls gets replaced with the output from ls, right? So that's what the echo does. Does that make sense? All right, so single quotes, double quotes, back quotes. Concepts about file systems. So the only things we really talked about are dot is a pseudonym for your current directory. Dot dot gets you to your parent directory, right? Hidden files are what?
The file names are-
Yeah, file names that start with a dot are called hidden files because by default ls does not show you those files, right? So so if I do an ls, there's no file listed called .secret, but there is a file called .secret. So if you say ls-a, you can see all your files, including .secret and dot and dot dot. We talked a little about links. Basically, a link is like a shortcut in Windows. It's a way to have one file refer to another file. And we can move around by saying directory / directory, right? So if I say ls/bin, it's looking for a directory named bin under slash, right? If I say ls/user/bin, it's looking for a file named bin under /user. If I say ls/user, that's the stuff in user, there's a directory named bin. If I do ls user games, it shows me that directory and so on. If I just say ls224, it's looking in my current directory for something named 224, right? Which exists because in my top level directory I've got a 224. All right, so setting variables, we can say variable equals value. So if you say x equals 2 plus 3, what is x equal to? Yeah, it's equal to 2 plus 3. Right, so this is very, very sort of literal. But if you want to evaluate 2 plus 3, you do the $paren, right? And if you want the value of a variable, we already said you do a $sign in front of it. You should know how to compile a C program. You've done that before, hopefully. So GCC is the command. If you say GCC-O followed by the name of an output file, it names your executable that output file. If you say GCC-C, it says compiled, but don't build an executable. And what does the -G switch do?
It allows for GDB.
Yeah, so it allows for GDB, brings in debugging information. So GDB, you should know, how many people here have been using GDB? It's one of those things that, like, you got to find a place where you simultaneously have a bug, but you're not in a rush. And that's a little bit of a rare combination sometimes, right? But if you find yourself in that situation, right, it's a good chance to sort of fire up GDB, recompile with a -G switch, hop into GDB, and after you do it a few times, you'll find out that it's pretty painless to use, and it's actually a whole lot easier for debugging. And then when you find a bug and you are in a rush, right, it'll make more sense to use GDB. So, so basic commands to know from GDB, right? So how do you run your program? GDB program. How do you compile? Right, just add start GDB by saying GDB in the program name. When you're ready to start running, you can say start. If you want to list your file's contents, you can say list. If you want to print the value of a variable, you can say print variable. If you want to examine the contents of memory, you can say X and put in a memory location.
And what is that again?
That examines the contents of memory location, loc. If you want to make a breakpoint, you can say break and put in a line number or the name of a function. You can say continue to say keep running until you hit a breakpoint. And you can say next to say go on to the next line of code. You can say step to say go through one line of code. So step over, step into. And I think those are the main things that we hit. Oh, that was weird. So don't underestimate the value of your print function, right? So I can print string and it shows me the value of string. I can print string length of string and it tells me string length will return 15. Even though I don't use string length in this function, right? GDB still knows about it. I can print string compare of string with hello and see that it returns a 12 because there's 12 characters between H and T, right? I can print f open of this is weird comma W, and I just called f open to create a file named this is weird, which is over there on the right. Right? You can do all this stuff. It's almost like interactive C when you're inside GDB. You can call C functions from the command line, right? Which is kind of cool. And now I got a weird file. All right, so basic GDB stuff. Make files. So how many people here have made a make file? Whoa, more than I expected. Cool. So review the basic setup for a make file, right? Pairs of lines, list the dependencies with a target, followed by a recipe for making the target if the dependencies are satisfied. And you build a make file, you call it make file, and when you say make, it goes through and it basically builds whatever your first target is by trying to satisfy the dependencies. So basic questions about that. Tar, gzip, gunzip, right? So tar is used to create an archive. It's used to take apart an archive. So I can say tar create verbose file my archive.tar star and it just added all this stuff to my archive.tar. So there's my archive file. If you say tvf, that shows you the contents of an archive. And so that's everything that's inside my archive. I can go into a temporary directory, which is completely empty right now. I can copy my archive.tar. So now my directory has one thing in it, which is the tar file. And if I say tar xvf, my archive.tar, now my directory is filled with everything that was in that archive. Right? So I just backed up my entire directory into a single file, which you can copy to a flash drive, you can send it to yourself in email, you can push it off to the server, whatever you like. And that one directory contains not only all my files, but all the information about what's in those files. The creation date and time, the size, the owner, the permissions, all of that stuff. Right? So it's way better than just copying files over, because it actually preserves everything about your setup. And it's recursive, right? If there's subdirectories, those will get lobbed into the archive as well. So if you want to back up your entire directory, just go into your home directory, do a tar cvf, archive name, period, and it'll put everything in your entire directory tree into that archive. All right, so I think that's it for basic Linux stuff. So Bash programming, we've talked about the number sign exclamation mark, right? That goes at the beginning of your file, and it's usually /bin/bash, which forces whatever shell you're running this through to use bash. Other than that, anything that has a number sign, everything after that is a comment, right? So you can document your code. We have these special variables. So what is $number? Number of arguments, right? $star, I don't know if we talked about that one. $1 is the first argument, $2 is the second argument. $star is a list of all the arguments. Okay, I won't ask you about that one because I don't think we went over it. And then $? gives you the return value from the previous instruction, the previous command. So it lets you know if a command returned a value. You can get it through $? Variable assignment we talked about. If then, else. So here's what I'm going to ask you to do if then else's. If you do anything different from this and it's not perfect, you get 0 points. If you do this and it's imperfect, you may get partial credit. So if space, bracket, bracket, space, condition, space, bracket, bracket, new line, then, new line, stuff, new line fee. Okay, if you remember this, you don't need to think too hard about how to do an if-then. Right, it always looks like this. And if you want to do an else, you can say else, more stuff, and fee. Or if you want to do an else if, you can say if, space, bracket, bracket, space, condition, space, bracket, bracket, new line, then, and then more stuff in fee, and so on. So if you're comparing strings, what should your condition look like? What kind of operators can you use to compare two strings?
Equal, less than.
So you can do equal, equal, or you can do exclamation mark equal. Right, this is if you're just trying to compare strings of symbols, right? So if $x equals quote hello, right? And it's usually good to put everything inside double quotes. Okay, if you want to compare numbers, if you're trying to compare yeah, question?
I was going to say, it's probably what you're about to ask, but like other kinds of comparison.
Yeah, So if you want to compare numeric values, use one of these. So this is equal, this is not equal.
So the top is for conditional statements only?
This, what do you mean the top?
That, yes.
This, so this is for strings. And this is for numbers. Right, so that's how I would compare a string in X to see if it's equal to the string hello. I would use equal, equal. And if I said X equal to buy, then they're not the same anymore. If I say dash EQ, it tells me that those are the same. Right? Why? Because I'm not supposed to use dash EQ for strings. If you're using strings, use equal, equal, or exclamation mark equal. If you're doing numbers, then you use dash EQ. Alright, so number of strings. Yeah.
We need the semicolon before the then too, right? Or is that?
Not if you do it like this.
Okay.
Okay. If you do it like this and then you go and you up arrow to get back to the previous line, it throws it on one statement. But I would say don't do that, right? Stick to that and you probably won't go wrong. All right, so we'll continue this tomorrow. We'll talk about loops and these other things, then we'll talk about C programming.